States of Matter and Stars by Noah Lowry, David Anselevich, Nehan Andrabi, and Clark Beatty.
The first of the three basic states of matter is the solid. In solid state, particles are arranged in a fixed position where they can vibrate in place. Solids have definite shape and volume. When enough energy is provided, a solid will melt into a liquid state. Solids can also sublimate directly into gas. Like in the case of carbon dioxide, there are two main types of solids. The first type of solid is called a crystalline solid. In a crystalline solid, the particles are arranged in a fixed pattern. This is the case for the sand, salt, and glass. The second type of solid is called the amorphous solid. Amorphous solids lack a pattern or crystal structure. Some amorphous solids include rubber and plastic.
The second state of matter is the liquid state. Liquid state, the particles are more free to move. Liquids have a definite volume but no definite shape. If you were to pour liquid into differently shaped containers, the liquids would take the shape of the container. With cold temperature, liquids can freeze into solid, or with high temperature, they can vaporize into a gas. A distinctive property of liquid is surface tension. It is the tendency for liquid to take up the smallest amount of surface area possible. Examples of liquids include water, mercury, and oil.
The third basic state of matter is gas. In the gas state, there is no definite shape and the particles can take up different volumes. Gases have a very low density compared to liquids and solids because of the space that they can take up. Examples of gases include neon and oxygen.
The birth of a star and the main sequence. Stars form in nebulae. Large amounts of energy cause hydrogen atoms to amass. The amount of mass dictates the life of the star. Hydrogen atoms will fuse into helium. Energy produced by the fusion will prevent the star from collapsing.
Red giant. Eventually, hydrogen fuel will be used up. Helium will become the new fuel source. Helium will produce carbon, which produces oxygen. Energy from fusion will expand the star into a red giant, and our sun will engulf Mercury and Venus.
For stars with small mass, the gravity will weaken and the atmosphere will expand into a planetary nebula. The core of a planetary nebula is called the white dwarf. Over time, the temperature of the white dwarf will decrease and it will slowly turn into a black dwarf.
Supernova. For stars with extremely large mass, fusion will cycle through all the elements up to iron. Iron is the final element of a star. The core collapses, followed by all the other layers. A powerful explosion called a supernova is created. Supernovae can cause other stars to be born.
Neutron stars and black holes. Supernovae leave behind neutron stars. Neutron stars are extremely dense. Magnetic field pulses are frequent around neutron stars. From the most massive of stars, black holes form. Black holes have an extreme force of gravity. The singularity could have an infinite density.
How do black holes die? Hawking radiation, discovered in 1947 by Stephen Hawking. Vacuums have changing energy because of virtual particles. Virtual particles do not violate conservation of energy. If one particle falls into a black hole while the other escapes, this could take 10 to the power of 100 years. Cosmology. To become a cosmologist, you should complete a four-year undergraduate in physics, astronomy, mathematics, or related areas, then complete 2 more years of master's education, followed by a doctoral education in astronomy. As a cosmologist, you must be precise in your data and have lots of patience, as findings take a lot of time in cosmology. You will be observing objects in space and studying them to find more about the origin of us and the universe. You will be using many modern technology and doing complex mathematical analyses on a day-to-day basis.
Thank you for your time!